In this video tutorial, we will be talking about how to use AudioGuide to create acoustic music, to write parts for instrumentalists. In AudioGuide, this is accomplished with the normal options file syntax and format, with a couple of additional objects that let you parameterize and modify how instruments can behave in time. And AudioGuide uses to create notation, to visualize notation, the Bach package in MaxMSP. This is an example of one of the scores we'll be talking about a little bit later today for string quartet that I created with AudioGuide. And AudioGuide gives you a whole host of different flexibilities for notation and how it appears on the page. You can customize playing techniques with text and articulation. Dynamics and pitches are all created and displayed automatically. You can also do a whole bunch of different things for restricting how individual instruments can behave in time in terms of how rapidly and dramatically their pitch can change over time, or how quickly they can change from one playing technique to another playing technique. To introduce this instrument's syntax and structure to you, we'll be talking about 4 examples. The first one will be a pretty quick and dirty oboe solo, and I'll use this to introduce you to the main workhorse objects of writing for instruments, which are the score and instrument objects in AudioGuide. I'll also talk to you a little bit about pitch and dynamics and how they work. In example number 2, we'll look at a more complicated solo part for a percussionist, where we'll look at a bunch of different playing techniques and how to customize how each one of them is notated in the score so that the symbolic information you want to appear in the score shows the way you want and is customized the way you want. We'll also talk about controlling the proximity of different playing techniques. The third example will be for string quartet. I'll talk to you about working with sustained notes in AudioGuide in instrument context, instrument writing context. I'll also talk to you about polyphony, how you can control the different ways that polyphonic selections can be made. In the final example, we'll look at options file that includes a violin part, but also a fixed media electronic part. And I'll talk to you about how you can use AudioGuide not just to write instrumental parts, but to essentially write mixed media parts all under the same programmatic paradigm. So let's kick things off with our oboe solo. This is an options file that I will be eventually adding information to about instruments. At the moment, it doesn't have any instrument information. It doesn't have the syntax and the objects you need to write acoustic music and to create proper acoustic parts with AudioGuide. But I want to start here just to give you a sense of the materials we're using and talk to you a little bit about what's in the options file that's important for you to know about. The first thing is that the target sound file we're using today is a short clip of some beatboxing. And for our corpus, as you can see, we simply have one corpus sound file object. We just have one resource in the corpus. And that is a directory, I'll open it here, of oboe sounds, all of which are staccato. This comes from a popular sound file database sample program. As you can hear, we've got all different pitches and dynamics, at least written into the file names, in this collection of staccato oboe sounds. We've got a pretty straightforward search routine where we're looking first at power and then at MFCCs to pick the best matching oboe sounds. And at the moment, I'm restricting the selection of how many oboe sounds can be picked using the superimpose object. This is documented very well in the video tutorial series, the 5-part series, when talking about density and layering. And so for the moment, we just simply have oboe sounds and a target sound file. I want to just run this so you get a sense of what we get out of it and what it sounds like. So here's example 1 before any instrument's infrastructure is added. Okay, so here we have up to 5 selections for each utterance, for each target segment that it finds. AudioGuide is allowed to pick up to 5 oboe sounds according to the criteria in the search parameters. Now, before we get to talking about the instrument stuff, it's important for me to say that AudioGuide in the package that you can download has a folder called MaxMSP. In that folder, there's a patch called Bach. There's a folder called Bach and a patch called AG Playback. Every concatenation you run in AudioGuide creates by default a Bach output called bachroll.txt in the output folder. Meaning even if you're not using instruments, you can load the sounds that you picked in the concatenation and visualize them or transform them however you like using Bach, the Bach package. So here I'm just going to go ahead and load the bachroll text file that we just made running our oboe example. And we can see here both our target and our staccato oboe folder represented as two different staves. You can see here we've got our wonderful crunchy 5-part oboe harmony. And you can play both target and selected corpus sounds, in this case the oboe sounds, within Max in this patch. So obviously this is not an incredibly playable oboe part. And to create an instrumental part in AudioGuide, there's now a new infrastructure that you add to help define instruments and how they can behave and make sure that AudioGuide picks the right number of sounds for an instrument such that it's playable and relatively idiomatic. What we do is we take the options file that we have already and we add a new variable called instruments. Instruments is set to an object called score. And inside the score is a list of as many instrument objects as you want. The instrument object is called instr. You can have one instrument and create a solo piece. You can have 10 instruments and create a 10 oboe piece if you like. There's a lot of optional keyword arguments that the instr objects take. I'll cover those shortly, but for now, let's do something simple. Let's create an oboe part. I'm going to call it oboe. And in order to make the instruments and infrastructure work, we have to link up the oboe part. We have to link up this instrument to entries in our corpus. You can't have an instrument unless it's linked to one or more CSF objects. The way we do this is we add, it's already written here in the options file, a corpus sound file keyword called instrTag, and we give it the same name oboe as our instrument has. Again, you can call these things, it doesn't have to be called oboe, you can call it whatever you want. All that matters here is that this instrument tag matches this instrument. You could create a second corpus sound file object, give it a different instrument tag, like, I don't know, trumpet. And then you could create a second instrument called trumpet. And effectively what this is doing is making it so that we've got two instruments and that this corpus sound file is essentially available to this instrument to be selected. To select these segments, the trumpet sounds are available for the trumpet for its part. You can also, of course, have more than one corpus sound file object with the same tag, and that simply means that all of the sounds tagged oboe are available to the oboe instrument to pick during selection. Let's keep things simple for now and just use the instruments infrastructure with the oboe linked up to one of the corpus sound file entries. If I run this whole thing again, we'll get a new output. I'm going to comment out the option that mixes the sound and of the target and the corpus together in the output sound file, and we'll just hear the oboe now. But here's what we get when we add the instruments infrastructure to the AudioGuide options file. If we load it into our Bach score, we'll see now that rather than having sort of cacophonous polyphonic selections, we now have a single selection of staccato oboe tone for each one of the target segments in the target staff. Now, it's important for me to say that, in the tutorial series, the 5-part tutorial series for AudioGuide, there's a whole section on density and layering revolving around the superimpose object. The superimpose object is kind of the global controller of density in AudioGuide, such that you can specify how many corpus sounds can be picked at the same time to match one target segment. And it's important for me to say that using instruments largely supersedes, or in a lot of ways disables or makes not very meaningful, the superimpose object. instruments sits in between the selection and superimpose, and essentially makes sure that AudioGuide isn't picking too many notes for a given instrument. By default, all instruments are monophonic. We'll talk about polyphony in example 3, but by default, all instruments are monophonic unless you say otherwise. And so here, even though AudioGuide is getting this superimposed parameterization that it can pick up to 5 segments, it's only going to be picking 1 because there's only 1 oboe. And once it picks as many sounds as it can for each instrument that's there, it doesn't pick any more. Obviously, if we had 2 oboes, now all of a sudden we'll start to get 2 notes picked per target segment because it's got 2 oboe parts to fill with notes. One thing that's cool about the instrument's infrastructure is that, again, it's a list of instrument objects in score. You can have as many as you want. Here I added a second oboe. Now I get a second oboe staff and a whole different set of selections. And for each target segment, AudioGuide is trying to pick 2 samples whose the sum of those 2 descriptors together approximates the target's descriptors that you are asking it to match. Okay. Let's back up a little bit. I want to talk about a few more things. The first thing I want to say is that instrument has a bunch of keywords. You can find these keywords in AudioGuide's documentation. Open AudioGuide's documentation quickly. If you go down to this section here called Using Bach to Create Notated Scores, you will find a whole section that discusses a lot of the things I'll talk about in today's tutorial. But one of the things you'll find a little ways down is the instrument object and an enumeration of all the different possible keyword arguments that you can give it, along with descriptions down here about exactly what they do. So the keyword arguments specify a bunch of different things about how the instrument can behave, how it's configured, how it's visualized, how it looks, how it's notated. One, by default, the clef keyword argument, for instance, is treble clef, which is written with G. We could also just as easily switch this other part to bass clef if we wanted to. And it's important for me to say that a lot of the keyword arguments like this, where you're specifying a text string, this text string gets passed directly to Bach. And Bach reads that text string and uses it to visualize your score. In other words, for things like clefs and articulation and noteheads, which we'll talk about later, you're specifying a certain text string in AudioGuide. AudioGuide doesn't care what you write, but Bach will. And so it's always good to look in Bach's documentation to see information about how to write different articulations, different clefs, different noteheads. They all have strings. You can find those all really easily in Bach's documents. So here I'll change oboe to, we're going back to 1 oboe now. We've got it in bass clef. And we'll see, what you would probably expect, a version of the solo oboe part we listened to before, this time written in bass clef. So there's a whole host of different instrument keyword arguments that parameterize, again, certain restrictions on this instrument and also how it's visualized. One of the most important ones, let's get rid of clef, because we should probably stay in treble clef, but one of the most important keyword arguments for you to know about for writing instruments and parameterizing how they behave is one called min speed. Min speed is a keyword argument for the instrument object that dictates how often, in what time in seconds, this instrument may pick notes. In other words, if I write a value of 0.5 for min speed, this oboe instrument may only pick a note every half of a second. If I write 1, this oboe instrument will only be able to pick a note every 1 second. And it's a brute force control for dealing with temporality and density and rhythm, but it's a powerful and really useful one. It's going to run it again here. It's important for me to say that when you reduce min speed to a very large value like 1 second, it doesn't necessarily mean you're always going to get a note every second. Rather, AudioGuide is going to look at the loudest notes in the target first, the loudest segments in the target, and pick a note for the loudest segment. They'll then move to the next softest segment, and as soon as it fills up its possible selections according to min speed, it will stop picking. As you can see, as a consequence, there are target segments here that aren't represented in the oboe part because we've restricted its temporal behavior to make it so that it can only pick one sound per second. I want to talk about another kind of brute force control now that comes from the keyword arguments. And that is, we're going to talk quickly about one called interval limit range per second. When I say it's brute force, I simply mean that it's kind of a crude control, yet I think it's a powerful one. Before I say it to anything, let's go back to our previous version. I'm just going to put min speed back to its default value of 0.075, which is pretty quick. Just load this in the Bach. Obviously, if you give this kind of part to a performer, it would be very difficult to play because, not necessarily because it's too fast rhythmically, but because there are very, very large leaps of 2 octaves or more on oboe, an instrument which is not particularly nimble as a wind. And one of the controls that AudioGuide lets you specify are a set of controls that specify how quickly in register an instrument may move across time. This one, interval limit range per second, simply says, in the time window of a second, the oboe is allowed to move X number of semitones. If I set this to 12, I'm essentially saying that for each sort of the sliding window of a second across time, the oboe may only have a maximum and minimum pitch of 12 semitones apart. We'll run it again, and you'll see here, but also see the effect of this parameter on making a part which is much more idiomatic and playable for the oboist. It's important for me to say what AudioGuide is doing here. So when it goes to pick a segment, AudioGuide has technically the entire folder of the staccato oboe sounds in front of it to choose. But when the restrictions come into play, it essentially turns off certain sounds that are not possible because they jump too high or because they happen too rapidly. And AudioGuide will then look at what's left and pick the best sound it can find. So at the expense of taking the best sample that is in your folder, AudioGuide is taking the best one given a set of restrictions you've given it in terms of how this instrument can behave. And this will become a kind of recurring theme, I suppose, in this tutorial video, that, at the expense of matching the descriptors as well as possible, and maybe also at the expense of timbral and variety across time, we're putting restrictions on in order that we can get something that's playable and manageable from an instrument writing point of view. Okay, that's all I want to do for this example when it comes to talking about keyword arguments. I'm going to dive into a bunch more in the next example when we look at writing for percussion. But again, one thing that's cool about the instrument's interface is that when you create 3 oboe objects, an oboe trio, they are independent from each other. They're limited in the same ways in terms of min speed, in terms of intervallic content, because I've written those keywords in, but they operate separately from each other. So here, if we run an oboe trio on this example with the staccato sounds, you can see that each oboe is kind of slotted into a certain part of pitch space. That's because they're all limited in this same way by interval limit range per second, but they're all independent from each other. So they're starting in different places in pitch range, and you get a lot more variety here now that we've got 3 different oboes in the mix. It's also, of course, important for me to say that because each instrument instance, each instr object, even if it has the same keyword like oboe, because they're all independent from each other, that means that it's possible to change the keyword arguments independently and create a situation like this, where here we've got, I don't know, let's say a first oboe player who's going to have a much more virtuosic part in terms of min speed and also in terms of jumpiness. And then we'll have oboes 2 and 3 who will play much less frequently and have a much more restricted intervallic range in terms of temporal restrictions. So here's our oboe trio with an unequal setting for the 3 instrumentalists. AudioGuide does its best to represent every target segment with notes. And so when you've got different min speeds that are a bit larger in certain instruments, you can see AudioGuide's actually hocketing them back and forth to do its best to try to represent all the different target segments, even if they're really rapid, too rapid for one instrument to do them all in a row. Okay, so that's the first example, our quick and dirty oboe solo. Before we go to example 2, there's a couple more things I have to tell you about pitch and about dynamics and where they come from. You'll note that when you load the Bach output file into the max patch that comes with AudioGuide, there are automatically present for you all the correct pitches in this case, as well as all of the dynamics for those pitches are written into Bach's standard slots. The dynamic slot is used. I want to say a quick word about how this works, because it's not necessarily super transparent and straightforward. The first thing I want to do is open the corpus sound file resource we're using. I want to open this folder of staccato sounds again. And I want to say a couple of things about what's here. So the first thing I want to say is that this comes from one of the commercial sound file instrument databases. And one of the unfortunate things about this particular database I'm using is that all of the sounds are normalized. That means that the forte sounds are the same dynamic as the piano sounds because they've been normalized in the production process, post-production process. And if we just use these as they're written in AudioGuide, it's not going to work or sound very good, because even though they're clearly of different dynamics, when we listen to them effectively in terms of computer measurements, they are more or less the same dynamic. They're all normalized. And so there's a very important keyword argument you should add when you're using corpus resources like this that are normalized, but have a dynamic written into the file name. As you can see, there's dynamics written into each of these different partitions of the sample database, specifying their dynamic. And if you set the corpus argument scale dB to file name din, file name dynamic, dyn, AudioGuide will automatically look for the dynamics that are written into the file names of each of these files and apply a scalar dB value so that internally they're treated like the proper dynamic rather than all being normalized to -3 dB. That's one important thing to know. The second important thing to say about this, as you might have guessed, is that because there are dynamics written into the file names, AudioGuide automatically looks for these, and then if it finds them, it puts them into the score. That's where these dynamics come from. And this is obviously easy when you've got a sound file database like this, where the dynamics are already here. In the next example, we won't have dynamics written into the file name, and I'll talk about how it works when AudioGuide can't find that information automatically. However, it's important for me to finally say, this is also true for pitch. Each of these file names in this directory have pitches written in. When AudioGuide loads sound files into a corpus like this, it looks at each file name and sees if it can find a pitch. If it does, it uses that pitch for musical writing. It uses that pitch for putting into this box score. If it doesn't find it, it's going to use the averaged F0, the average fundamental frequency descriptor that AudioGuide calculates when it analyzes it. These descriptors are not always very good and very accurate at giving you the pitches you want or giving you sensible results. And I'll talk in the next example about how to deal with that when it comes to working with sound files that don't have pitch information or dynamic information written into their file names. But that's all for now for example 1. The next example is a little bit more complicated. In this example, we're using the same target sound file that we've been using thus far, this wonderful beatboxing sound file. I'm just going to play it for you to remind you of its glory. And I actually, for this example, for this video tutorial, recorded my own corpus for the purposes of this video. And I recorded a corpus of sounds that I made using a turned over metal salad bowl. Using a couple different mallets. I actually made videos as I was going. So I used a couple different mallets to hit the salad bowl. I used a yarn mallet. I also used a metal beater as well. I did a sample session where for each mallet and playing technique, I recorded a couple of different hits in a row at different dynamics to try to capture the dynamic variability and spectral differences in terms of dynamic change. But otherwise, I just simply recorded each of these in a separate video and gave them a name that described what I was doing, what mallet I was using, where I was playing, and what technique I was using to play. For instance, in a couple of the videos, I'm playing on the side of the instrument, the side of the bowl, as opposed to the top. Some of them I'm doing a dead stick technique. It'll be better in this one. And finally, I'm also scraping sometimes with the metal beater here. Okay, so I made these videos. I made them with my phone. I think one of the sort of a side note is that I think one of the cool things about using concatenative synthesis to write instrumental parts is that the quality of the recording doesn't have to actually be that amazing. I mean, as long as you have a half decent microphone and you're capturing, orally the spectral differences between different kinds of techniques or different ways of playing the instrument, you're largely going to capture what you need to have AudioGuide make good choices about which techniques to use. So I recorded these with my phone, made these different videos. I extracted the sound from them, and then I used AudioGuide's AG segment SF script, comes with the program, to look at each one of those chunks of repeated articulations and break them into individual corpus sounds. Okay, so that's the genesis of this of these corpus sounds. And here I have an option file that has our beatboxing target. And then, as you can see in the corpus, I simply have each one of those. It looks like we have 10 sound files. All of them are tagged with an instr called bowl. And as you would probably expect, in the score, I have one instrument called bowl. So this instrument is linked up to all of these corpus resources, all 10 different playing techniques and mallets and stuff. And all I've done is give it a percussion clef. Okay, so let's load it up, and here's how it sounds. Okay, so that's both the target and the selected bowl sounds at the same time. Let's load it into Max MSP and see how it looks. Here we have both a representation of the target sound file and our instrument called bowl. And as you can see, it doesn't look great. I mean, going back to what I was talking about before with pitch, here we're working with a set of sound files that don't have pitch names written in, which is fine. But what that means is that AudioGuide is then going to look to the F0 descriptor to try to approximate the different pitches that it writes in the score to get some pitch variety in terms of what's being written. And if we listen to individual sounds, you can hear that some are more or less on pitch. Other ones are written on higher or lower pitches because of spectral properties, like the scrapes, that essentially mess up the F0 fundamental frequency estimation. The good news is that AudioGuide lets you override how MIDI pitch is approximated for any corpus sound with something called MIDI pitch method. It's documented in AudioGuide's documentation in the corpus section. There's a lot of different possibilities for what values you can give to MIDI pitch method to do different kinds of things. Check that out. I'll talk about another one a little bit later, but for now, I just want to say that the simplest thing you can do is set MIDI pitch method to a float. Setting it to a float will just tell AudioGuide that every sound segment in this corpus sound file resource will be set to this MIDI pitch, in this case, the F5, which will be the top of this line. So obviously, writing a percussion part, there's lots of different possibilities for how you might structure pitch. In this case, I'm just going to say that I want all of the times when I'm asking the player to play the bowl in the center to be on the top of the staff on MIDI pitch 77. And I'm going to have all the times when I'm asking the player to play the side of the instrument to be lower. So here's all the center pitches at 77. Here I'm going to do 64 for playing on the side of the bowl. That should be the bottom line of the percussion staff, E4. There we go. And I'm going to run AudioGuide again now, and you're not going to hear any difference in the sounds that were selected. It's all going to be the same. All I'm doing now is changing things that's going to affect the output score, the Bach score, how it's notated. So here is, we'll run it again. And now if we load our concatenation into Bach, we'll see that essentially all the pitches have been cleaned up. And now pitches being used in a meaningful way. Essentially, we're creating a really small drum map. Two different pitches are used to specify two different locations on our instrument. So I want to continue looking through this corpus, and I want to try to figure out ways to put into the score, into the notation, all of these different playing techniques and all of these different sort of sticks and mallets and ways of striking the instrument, so that all that information is getting into the symbolic output, the Bach score. The first thing I want to do is introduce you to another important control for instruments, and that is that for each CSF object, you can specify an instrument tag to link it to an instrument, but there's also something called instRParams. instRParams is set to a dictionary, and in this dictionary is where you put information about articulation and text that goes above the noteheads and is linked to each note. It's where you put information about what notehead to use, and a whole host of other things go into this dictionary. So to start off, let's go ahead and add some text above notes to help specify which mallets are being used. To do that, I'm using Bach's syntax here. They call text above the notes annotations. And so I'm going to add an annotation to this first corpus item called metal. That means that any note that's picked from this corpus CSF object right here will now appear in the score with the word metal above it. You can see a couple of them peppered throughout the score. And I'm going to go ahead and go through and do this for the entire corpus. As you will probably guess, I'm going to use the annotation metal for anything that's using the metal stick. I'm going to switch that annotation to be yarn for anything that's using the yarn stick. And now when we run our example again, we'll hear all the same stuff on the output in terms of selected notes. Now, obviously, every note is also tagged with an annotation that says what playing implement is being used. Bach has a handy thing called thin annotations that you can set to remove with bracket that make it a little bit more readable when you've got lots of text in a row. Essentially, it groups common annotations together of successive notes and puts a bracket to make it a little bit easier to read on the page. Okay, so that's one kind of way we can use instrument params to tag certain notes of our corpus in a particular way, using text, using the annotation. I now want to do one other thing, which is that I want to make these dead stick notes where we hit the bowl and don't let the stick bounce, but push it down into the bowl and create a drier sound. I'm going to go ahead and notate these with articulation. I'm going to use articulation, the staccato indication, to notate a dead stroke. Articulation, staccato. Again, I mentioned this before, but if you write an articulation into the instrument params of any corpus sound file object, the string that you write here gets passed on to Bach. And as long as you're using a term that Bach understands and uses, like accent or tenuto or staccato, it will work in the output score. So let's use a staccato articulation for any of our dead stroked notes. Looks like we've got another one here, another one down here. Now this will mean that anytime we get one of our three corpus entries that has a dead stick technique, it should be notated in staccato. You can see the staccato marks on some of our notes indicating the dead stroke technique. Okay. And the final piece of information I want to capture from our original corpus are the scrapes. Again, there's probably a ton of different ways you could notate this for a percussionist, depending on what you are doing. Here, I'm just going to go ahead and change the note head of any of the notes that have the scrape technique to use a cross note head. Again, the string that you write into the note head key in the instrument params dictionary should be something that Bach understands. In this case, I'll use X, which Bach will translate into a cross note head for me. And I'll add it to both of the scrape elements. And this is more or less, I think now, a completely marked up score. In other words, we've taken our corpus and done things for each of the different flavors of salad bowl playing to make sure that they all have a distinct notation in the score, from mallets and pitches to denote playing location, staccatos to note dead sticks, and X note heads to denote scrapes. Okay, so for the last 10 or so minutes, I've tried to give you an overview of some of the ways you can customize notation in AudioGuide. And one of the reasons, of course, this is important is you'll likely have different corpus resources for a given instrument grouped together in different sound file objects. And this lets you apply a certain notation or articulation or annotation to different entries so that they have a custom visualization of the score. I want to now do a couple more things with this options file in this example that will change the selections you're hearing. And I want to do a couple things that make this passage a little bit more playable for a percussionist. I mean, if you look at it as written, there's a couple of very challenging things about playing this as a percussionist. If you've got a salad bowl and some mallets and you're asked to play this, one of the things that's probably going to come up is that some of the techniques happen in really rapid succession. And so, for instance, here we've got two scrapes, really very quickly in quick succession. They're right in a row. And one of the things you'll find as you're starting to work with building a corpus to make it work for an instrumentalist is that some techniques have different rates at which you can do them than others. If a percussionist is playing with two yarn mallets, they can do a roll and do successive articulations really quickly on the instrument. If they've got two metal scrapers and they're trying to scrape as fast as they can, it takes a little bit more time. And one of the important things I want to tell you about instrument params is that it is not just a dictionary where you can write stuff about notation like we've done so far. It's also a place where you can override almost all of the parameters that are written in the instrument object as keywords. So right now, by default, the min speed for any instrument in AudioGuide that you create is 0.075, 12 notes a second. So really rapid. And this might be more or less possible for two mallets, yeah, but it's certainly not possible for scraping. It takes more time to prepare. Scrape gestures have more duration. And so to make scrapes happen less frequently and less densely, we are going to override min speed just for the scrapes, let's say to a value of 0.4. So for every other instrument where we don't override it, the min speed is going to be what's specified here. For every other corpus sound file entry, unless we override it, we're going to have that as our min speed. However, for the scrape here and the scrape here, I'm adding a min speed of 0.04. That means a scrape can only happen every 0.4 seconds, every 400 milliseconds. And so we should see when I run this again, the density of scrapes drop because AudioGuide won't be able to pick so many scrapes in quick succession because they're difficult to perform. So as you can see, fewer X note heads now. There's still some chosen. But when AudioGuide wants to pick another X note head on, let's say, this pitch, those X note heads are now unavailable to it, and it's going to pick something else as a substitute, the next best thing it can find, which in this case is which sounds like a dead stroke or at least a hit on the side of the bowl with a metal mallet. Okay? So instrument params is really important, not just for specifying notation properties, but also for overriding pretty much any of the arguments in the instrument object. You can find a list of which ones you can override and not by going to this section we looked at before on the instrument object. The ones with asterisks cannot be overridden. So most of them don't, and that means they can all be customized, more finely tuned in individual CSF entries. Okay, so anything else I have to tell you about this? Yeah, back to playability. So we've now made this slightly more playable from the perspective of the scrape note heads, right? But one big problem still with this percussion part is that we're switching really rapidly back and forth between our yarn mallet and our metal mallet. We have two different playing techniques, and of course in percussion, it takes time to set down one set of sticks and pick up another set of sticks. I want to talk about two solutions to this. The first one is a little bit more specific to percussion. The next one will be more general and a little bit more fiddly, but more general and therefore more powerful because it can be applied to lots more different kinds of instruments. So one approach to this problem, from an instrumental point of view, is that you could certainly imagine writing a passage of music where one hand has the yarn mallet, one hand has the metal mallet, and therefore, we should be able to reduce the min speed somewhat and assume that the percussionist can do both. They should also be able to play both at the same time, though, the yarn and the triangle beater. And so one solution to this problem is actually to have a percussionist who has two different staves. We're going to call this bowl left hand and bowl right hand. So we're making effectively two different instruments here that are going to eventually, in your compositional process, become part of the same percussion part. But here we're writing it with two different instrument names. And I'm just going to put all of the metal corpus entries into the left hand. I'm going to put all the yarn into the right hand instrument. And because they're using one hand now, I'm going to reduce the minimum speed to be a little bit slower, since they can't do really fast alternations now between two hands. The cool thing about this approach is we'll not only get two different parts with a different stick in each hand, we'll also get it so that sometimes if the program finds a good place to have two sounds at the same time, the two hands are going to play together. So here's this two-stave version of our percussion part using the bowl sounds. I'm just going to comment out the targets so we don't keep listening to the beatboxing. Let's just listen to our bowl. So again, all the metals in one hand, all the yarns in another. And this is, I think, a pretty good solution. But let's undo this, remove all the stuff I just put in. Let's go back to one percussion part. This is actually a really common problem. I mean, I know not all instruments play with sticks, but this idea of having different playing techniques that it takes time to switch between is something that I've encountered a lot as I've tried to build this instrument's infrastructure. For instance, we'll look at strings next, and string players need time to switch between arco and pizzicato techniques. And so AudioGuide also gives you a way to essentially set up a list of different kinds of delays for how long it takes to move from one kind of playing technique to another kind. And I want to give you an example of that now. It is called, so it's an instr object keyword. It's called technique, switch, delay, map. And before I put anything in it, the first step to making this work is that in the instrParams dictionary, we have to add a keyword argument called technique and set it to some string. I'm just going to use M for metal and quickly populate all of the metallic sounds in my corpus with the technique M. The technique keyword is not something you're going to see in the notation at all. It's only something that AudioGuide holds internally to identify this sound as having a certain technique. For the yarn mallets, I'm going to put in technique equals Y. Okay, so they're now, each corpus entry is tagged with a technique, either M or Y for metal or yarn. And we'll come back to technique, switch, delay map. You can look this up in the documentation for more details, but it is a list of lists. And essentially the way it works is, it's 3-item lists, and you say to go, I'm going to type it out, and as I'm typing, I will kind of read it out in language. To go from M to Y, it takes half a second. And we're going to do the reverse now. To go from Y to M, it takes, let's say, 0.6 seconds. I mean, in real life, a percussionist, it should take the same amount of time to switch from one mallet than to do the reverse. But for some instrumentalists, they can quickly switch to one technique, but it takes more time to switch back to the technique they started from. And that's why technique switch delay map lets you specify moving from one and then moving the other direction as independent numbers. So here we have our technique switch delay map. This will now mean that anytime the percussionist wants to move from anytime AudioGuide isn't playing metal sounds and wants to pick a yarn sound, it has to make sure that that yarn sound is at least half a second away from the metal sound. So you can see this whole second half of the excerpt is almost entirely yarn. And again, I'll come back to this point I made earlier about these kinds of restrictions that AudioGuide lets you put on the temporal behavior of an instrument. You know, there is a bit less temporal variety here for sure than before we added this restriction, but at the expense of temporal variety, we now get a part which is playable. We now get something which a performer could feasibly do and is reasonably idiomatic. So here we're using technique switch delay map to make sure that there is enough time in seconds between switching different techniques such that all the notes and the gestures are more or less playable. You'll note that, like the previous oboe example, that means that there are notes that didn't get a note in the percussion part assigned to them. That's because AudioGuide couldn't find a note between these two because it had to leave the requisite space. The final thing I'll do is just quickly point out that one of the ways to get that spectral dynamism back, to get that variety back in the sound, is write a second percussion part. Here we'll just add a second bowl with a percussionist using all the same stuff. Technique switch delay maps are all the same. And now, because AudioGuide has a second percussionist at its disposal, it's going to fill in a lot of these gaps that were created by the fact that it had to give time between switching from one technique to another technique. I'm going to remove the beatbox, so you can just hear the bowls, and you'll hear a lot more temporal variety, spectral variety in this. I want to talk to you about the third example, which is the example that we started in this video looking at, the string quartet example. As you can see, it's a really big options file. It's got lots of stuff in it. And there's a couple of important topics I want to talk about. And to do that, I actually want to quickly just have a kind of smaller options file where we look at writing for violin with just one corpus entry and just our target sound file, so I can talk you through a couple of things, namely sustains and duration, and also polyphony. For this example, we're going to be using the target sound file that comes with the AudioGuide distribution of John Cage speaking.
The lecture is so soon that I don't think.
Okay, and for our corpus of sound files, we're going to be using a folder of violin sounds that are sustains. So here we've got a little bit like the oboe folder, a bunch of different sound files that have pitches and dynamics written to the file name right before us, which is great. And as you can hear, each sound file is about 7 to 10 seconds long. Okay. Now, the first thing I'll say about using resources like this, I'll just reiterate again that this, like the oboe resource we were looking at before, is entirely normalized. And so I am going to add this very important keyword argument, scale dB equals file name dynamic, which will make it so that even though this is a normalized corpus resource, everything will get scaled to the right amplitude according to the dynamic that's written into the file name. Let's just go ahead and start by running this example. Again, John Cage target and a folder of violin sustain steps. It's very pretty, and actually kind of not uninteresting as an output, but probably not what you were expecting. As you can see, the violin notes are starting with each segment of John Cage's voice, but they last their entire duration. And this is something that AudioGuide does by default. If you give AudioGuide a folder of corpus sounds that are all 5 seconds long each, and then it picks one of them to match a target sound, which is only 1 second, AudioGuide's actually going to play the full 5-second sound. For instrument writing and for sustains, like these sustained violin notes, this is broadly not what we want. And so there's another important keyword argument that you should use when you have sustained sounds. In other words, when you have a corpus sound that is longer than the target sounds are, and you want that corpus sound to be clipped so that it matches the target's duration. This is not something that we really have to worry about in pizzicato or percussive sounds. You know, they can be longer than the target and it still makes sense to just include their full duration in the score as well as in the audio that's rendered. But here we want to clip those so that they are they tightly match the durations of John Cage segments. So we're going to add this funny looking keyword argument to our sustained sample, our non-vibrato violin folder called clip duration to target equals true. We're going to run it again. Okay, so now we've got the durations matching. It sounds kind of weird and you don't always hear the sample sometimes. That's because a lot of these sounds kind of start really quiet. And for a really short duration note, it tends to not be very audible because the start of notes can be on the quieter side. But to get around this problem, one final keyword you might find useful is that there's something for CSF objects called whole file min start equals some value. I'm going to set it so that each of the files of this directory, whole file min start, are going to start 50 milliseconds into the sound file, just to make it a little bit more clear and audible. Here's what we get. They don't sound as good as the percussive sounds because we're clipping the start time and clipping the stop time. And so there's a bit of an artificialness to it. That shouldn't really affect the fidelity of the matching. The matches should still be good. It's just that because we've got these long samples, when we listen to it, it's not necessarily the most satisfying sound or result possible. Okay, one other thing I want to talk about before we get on to talking about our full-fledged string quartet example is polyphony. Like I've said, by default, every instrument in AudioGuide is monophonic. And so we've created a violin, we've tagged this folder of legato, non-vibrato sounds to the violin, and AudioGuide is only going to pick monophonic selections. But as you can see in the instrument definition area of the documentation, there are a bunch of keywords that deal with polyphony. The most important one is polyphony max voices. This tells AudioGuide how many voices it can pick, how many notes, how many chord notes you can pick for this instrument per target segment. By default, it's 1, hence every instrument is by default monophonic. Here I'll set it to 2. Okay, we clearly have dyads now, but a lot of them are unplayable because they're really far apart. The distance, the interval and semitones between the lowest note and the highest note, generally you're looking for an octave, maybe a tenth or something like that on violin. Certainly you don't want to write something wider than that. And in addition to simply specifying the number of voices, you can also specify in AudioGuide the max range of the polyphony. So what's the maximum distance between the highest note and the lowest note of the chord, as well as the minimum range. For a quick and dirty polyphony, sort of dyads, double stops for violins, I'm going to say max range equals 8, major sixth, and I'm going to say min range equals minor third equals 3. Stuff is always in AudioGuide in semitones or in MIDI. So here, max range and min range are going to get rid of those selections that are too large to be playable as double stops. Kind of soft. But so that's some of the crude controls that polyphony gives you. And already it's looking much better in terms of playability here. One final thing I want to say about polyphony, well, actually there's two final things. The first is that there are also, just to give you some other ideas about what's here, you can include or exclude certain intervals based on what you're going for. So here, let's say I don't want to have any perfect fifths. And so I'm going to say polyphony exclude intervals and give it a list, including the number 7 in it. 7 is a perfect fifth in semitones. And this will exclude perfect fifths from the polyphonic choices that it makes for this violin part. Do we have any perfect fifths? Yeah, here we go. Here's a perfect fifth right here. I'll run it again, and this should, if I'm lucky, disappear. So now this has changed to a different selection. AudioGuide picked this B first. It would have picked the F sharp, but we disabled that. And so instead it picked the G below. Okay. The final thing I want to say about polyphony, a very important control, is that polyphony has its own minimum speed, which is important, right? Minimum speed, min speed is the thing that says how rapidly adjacent note onsets can happen. And you can have one min speed for the instrument for all selections, but you can have another min speed only for the polyphonic selections for that instrument. And this is important because double stops on violin are harder to play rapidly, obviously, than single notes are. And so here we're going to add a polyphonic min speed, saying that, well, by default, the min speed is going to be 0.075 seconds. Polyphonic selections can only happen every 0.4 seconds. We'll now see, when I load the score, a big reduction in the number of dyads because we've restricted how densely in time two-note chords can be picked. So now we have a violin passage. Actually, that's a lot, I think, probably reasonably playable in terms of double stops, in terms of polyphony, and also we've sort of finely tuned some maybe intervallic preferences, like getting rid of things like perfect fifths. Okay, now I want to move on to the full example. So this is the same target sound file, John Cage, that we have been using for the solo violin so far.
The lecture is so soon.
But as you can see in my corpus, I've got a lot more stuff. I've got a bunch of different violin sounds, both short articulate sounds as well as long sustained sounds where I use clip duration to target. But then I've also got a bunch of viola sounds of a similar fashion. And I've got cello sounds. Again, more or less each of these three groups covers the same space. I've got some articulate notes, staccatos, pizzes. I've got some sustained notes, including vibrato, but also solpant and soltasto and harmonics. Okay. Obviously, solpant and soltasto are tagged with text like SP and ST that will help annotate in the score anytime it picks one of these techniques. So it's visible in the output score. Harmonics also has the word harmonic written above it, so we'll be able to see those. Ditto for pizzicato. I have implemented in this options file a technique switch delay map between pizz and arco. It takes 0.4 seconds to get from pizz to arco. It takes 0.6 seconds to get from arco to pizz, which I think as a minimum is probably about right. And so the pizzicato sounds and the arco sounds will always have some distance between them to allow for the players to have that switch. Finally, I have polyphony written into each of the instruments, more or less along the same lines that we had in the previous options file. So max voices is 2, between a minor third and a major sixth, and a min speed of 0.4. For selection, I'm looking at amplitude first in the search, then I'm using parser to find how noisy the sound is. If it's reasonably noisy, the John Cage segment is reasonably noisy, a vowel, consonant or a fricative sound, I use MMCCs. If it's reasonably pitched, I use F0 to pick the best sounds from the corpus from my large collection. There's a couple other things to mention. I've got some pitch restriction using a different keyword called interval limit breakpoints. You can check that out in documentation. It's a bit more sophisticated than the thing we did with the oboe part. But I just want to spend a little time and talk about one entry in here before I render the full example for you. And that is this one here. I've got for each of my string instruments a folder full of scratch tones. This is the violin one here. As you can see, there are no pitches written into the file names. I only have string numbers in this particular directory. And so what I've actually done is used a different kind of MIDI pitch method, which you can find out about in the documentation of AudioGuide, called file match, where it looks to match a partial string in the file's name. And if it finds a match, it assigns the string that pitch. So here I just use the open string pitches on the violin and assign them to these file match strings accordingly. I also use an accented note head to denote the scratch tone and the staccato mark, because they're all short. The very final thing I want to say about this is that by default in AudioGuide, if you don't have dynamics written into the file names, AudioGuide will look at a corpus CSF collection of segments, and it will look at order them from loudest to softest, and apply dynamics from fortissimo all the way down to pianissimo, and that's the dynamics you'll get in the output score. You can override that with the dynamics keyword of the instrument params. Here I'm saying that this scratch tone folder can only be mezzo forte, forte, or fortissimo. AudioGuide will look at the amplitudes of all the sounds in that folder and assign them one of those three accordingly. Again, you can see more about dynamics in the documentation for AudioGuide. So some cool stuff here happening from a notation perspective with the scratch tones for each of the three string instruments. Okay, let's run the example. So 2 violins, viola, and cello. It'll take a little bit longer than other concatenations we've done today, simply because we've got a much bigger pool of sounds to pick from. We're looking at about 250 minutes worth of corpus audio.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
So as you can see here, we've got lots of techniques and information written into the score. Like I talked about at the very start of this video, we've got things like soprano cello denoted, soltasto, harmonics, all of that stuff is written in annotations. We've also got articulation, staccato notes or staccato. The scratch tones have this accent note head and have appropriate dynamics. There's time given between arco notes, in this case the scratch tone, and these pizzicato notes. In the cello parts, the player has time to switch back and forth between one technique like soprano cello and another pizzicato. And finally, you can see there's multiple stops, but they're all reasonably playable, if a little high on the viola. Reasonably idiomatic intervals on the double stops for all of the instruments that we're working with here. Okay, so that is our string quartet example. I want to say a couple more things about this example to give you a couple more ideas about possibilities with AudioGuide instrument writing with respect to AudioGuide's other features. So those of you who have watched the tutorial will know that I did a whole section on the tutorial on corpus filtering, where you can add different things into the CSF objects that filter out certain sounds according to some feature. I'm going to do that here with corpus global attributes, which lets you specify attributes for your entire corpus of CSF objects. In other words, if I write whole file equals true here, that will mean that all of these are using whole files. I don't have to write it over and over again in each CSF. And so here I'm going to add a limit object. I'm going to filter the corpus according to amplitude. And I'm going to say that I'm only going to take the softest 40% of sounds in my corpus, and I'm going to discard everything else. I'll run the same thing, and now I'll get another version of this string quartet output using only the softest 40% of sounds in this entire collection of string material. So she gets something now which is on the whole quite a bit softer than the version we just listened to.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
Didn't quite keep up there with the playback. As you can see, much softer written dynamics, which makes sense because we're picking the softer side of the samples from the corpus. So these filters are still operable and still really useful. Just to give you another example, here's our friend pitch filter. Pitch filter filters out certain pitches of the corpus and keeps others. I'm going to use the pitch filter attribute called harmonics and specify C2. That means that C2 will be used in this example plus all of its harmonics. So here we'll try this again now with a pitch filter.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
Okay, so here we have just tuned harmonics from the C2 harmonic series, which now form the basis of the pitch materials for our corpus. Okay, so the filters are still there. and the corpus filter mechanisms are still super useful in the instrument writing context. The next thing I want to say is that I want to give a little attention to superimpose. I've told you thus far that superimpose really isn't important, which is more or less true, in the sense that the instrument's infrastructure will govern the density of selections from the corpus. It will create a hard upper limit on how many notes can be picked per instrument. But it's still possible to use superimpose to make more rarefied or less dense concatenations. Here I'm going to set the max segment keyword of superimpose to 2. And this will mean that for each John Cage segment, AudioGuide can only pick 2 sounds from the corpus. It's been picking many more than 2 sounds thus far, because it has all these instruments available at its disposal, and it tends to like to fill up the selections. But here we'll get a much more rarefied result, a much less dense result in terms of what we get through into the output score.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
So here we get a much more pixelated, less dense output because we're using superimpose as to give a maximum ceiling, which is much lower than what the instruments could actually support on their own to make this more rarefied sound. The final thing I want to say about writing for instruments is that obviously the Bach score, you can listen to things and play them back and highlight individual parts, solo them and play them back. But it's also worth noting that in the C sound output, in the rendered sound file that we're listening to at the command line automatically after each of these examples, by default it's stereo, and things are put into the stereo field as stereo sound files. But there is a way to make it so that each instrument in your score gets its own channel. Here I'm going to set C sound channel render method to 1 channel per instrument. Run it one last time. And the output sound file that AudioGuide makes, which is going to be in our outputs folder, will now have 4 channels. Violin will be on channel 1, violin 2, channel 2, viola and cello on 3 and 4. Open this in Audacity so we can see. Here are our 4 instruments parsed into 4 separate tracks. Okay? So another way of auditioning, listening to, inspecting different instruments and what they're doing is using the C sound output, C sound channel rendering method. Okay, for the final example, I'm going to do something pretty brief. We're going to look at mixed media writing with AudioGuide. And it's just really, this example's for me to sort of tell you about this last possibility. Here I've basically taken the violin stuff from the previous example, got rid of the viola sounds, the cello sounds, but I just kept the violin. And I'm making essentially a solo violin piece using the John Cage target. Let's just run this really fast so we can hear what our solo violin part sounds like. Okay, that is our solo violin part according to John Cage with all the restrictions from the previous example. One thing I want to say, however, is it's still possible to have CSF objects that aren't tagged with any instrument. I mean, here we've got violin and our instruments. All of these sounds are, of course, tagged as violin with their instrument tag. Here I'm going to add another corpus sound file entry that doesn't have any instrument tag at all. And AudioGuide is essentially going to treat this like it has no limits, just like it would have treated it before the instrument's infrastructure was being used. In other words, superimpose will govern its density because there's no instrument code that's deciding how dense it can be or what sounds can be picked. As a consequence, we're going to get violin sounds plus, this is like a big collection of kind of glitchy sound files. And effectively what I'll be making is a mixed media piece. I'll be writing, AudioGuide will be making me a violin part according to all the rules and stuff we talked about in the previous video, but it'll also be picking sounds that mix with it from an electronic resource, a fixed media resource. And these will be these will be notated in the Bach score alongside the violin, so we can look at them. Okay, so again, no instrument tag on this CSF will have it be selected in an unrestricted way. I'm restricting selection by using the restrict overlaps keyword, which says that only up to 3 sounds from this corpus can be picked. So here for each John Cage segment, like this one,
T, T, T.
We have a couple selections from our glitchy electronic resource and the violin harmonic. Pretty soft. And the cool thing about this is that AudioGuide is looking at this target segment of John Cage, and it's picking these 4 things, 3 from the electronic part and 1 from the acoustic part, that spectrally sum together to try to approximate the MFCCs of that original target segment. So, normally we think about doing acoustic composition and electronic composition in different separate programmatic planes. But here AudioGuide's integrating choices about what sounds are picked for the instruments and what sounds are picked potentially for a fixed media or electronic playback part in a really integrated way, such that the spectral sum of both of those things together is trying to approximate the target sound file. That's all for this tutorial video. Long and detailed, but I hope it was interesting and a good watch. Again, don't forget to check out the documentation for like a really full and more clear explanation of lots of these things and as a resource as you go building your own instruments. It can feel a bit unwieldy and like a lot of typing to put together an instrument for the first time. But once you get all this stuff the way you want it, articulation, annotation, noteheads, once you get all that stuff in place, there's a lot of stuff you can do, different targets, different descriptors to get a lot of different sounds and outcomes out of a given instrument and do lots of different interesting instrument writing. Below this video, you'll find a link. In that link, you will find, it will take you to the AudioGuide page and you'll find links to all of the options files I've been using today, along with the target files I've been using for a couple of the examples, as well as the example number 2, the sounds I made with the salad bowl. You can actually download that example in its entirety and run it on your machine and check your results.